have been sort of, deemed to be acceptable for flight use, or is sort of more tolerant to the harsh environment that we're subjecting them to. So that's how this OBC Lite comes about, is we select components that are at least, or at the very least, tolerant to the total dose of radiation up to some level or beyond. And other than that, it's sort of a stock OpenRISC with the modifications that we put inside that are kind of invisible to the user. And so toolchain-wise, it should just work with exactly the same toolchain that everybody else is using. The machine code that we compile and everything is going to be pretty much the same. So anyway, for an example system, we have this OBC Lite at the top, and this one has sort of it has the Ethernet so that you can do very convenient things with loading the kernel over TFTP through U-boot, or using FTP to load your user applications and all of that. So it has sort of the extra features. And then down at the bottom level, we have our slave devices. So this is sort of a model where certain products of ours are meant to interface with things in the physical world, while the OBC Lite is sort of supposed to be the center of the system. It's supposed to be the host while you have your slaves at the bottom. And then in between, we offer certain things like the distributed power control unit. And so, for example, this could be the one for the USB, or there are other protocols such as I2C or SpaceWire, which we're also either currently using or going to use. And this handles both the routing of the multiple communication ports as well as the sort of switching on-off of all of your devices, or making sure that something isn't consuming too much current. Let's say you have a latch up which causes one of your transistors to get into a funny state and suck a bunch of current out, and everything's blowing up. Then all of a sudden it goes, whoa, this guy's consuming way too much current. We're going to automatically cut this port off and notify our host. So we have a bunch of fault tolerance features sort of at that level as well. I feel like I'm going very quickly because I have so much
this is
details.
good. Yeah.
So, that's sort of the overview of the different levels of what we're doing. Not everything that we do actually has OpenRISC inside it. For example, currently this power control unit, for USB, it has sort of an off-the-shelf USB hub that has been screened for radiation performance. And so no, it's not an actual rad-tolerant device, but it's been screened and compared to other things, and it was the one that performed the best. And then on top of that, we have another sort of processing unit, and up until this point it hasn't been OpenRISC because it's supposed to be a lot smaller and lighter weight. And we found out, thanks to this guy's good work, that actually we might be able to fit a very trimmed down version of OpenRISC on top of that. But anyway, currently this guy's not OpenRISC. And then these guys at the bottom, some of them are and some of them are not. It depends on sort of what's the complexity of the actual application. That we could have the smaller device which uses the PIC core instead of the OpenRISC, or we could have an OpenRISC down there. So that's sort of the overview of the different levels of what we offer in hardware. So I'd like to talk a little bit about what we're doing in software. And this, is, of course, originated from the space community, and we find it interesting to use for space, but at the same time, it's now actually a little bit more opened up than it used to be. And I'll get into that a little bit later. But I do think that it could be viable for applications other than space. Maybe not for general computing applications, like if you're talking about networking or that kind of stuff, that's a little bit outside the scope of what it covers. But more for anything sort of automation or industrial, or anything where you have sort of some kind of sensors or some kind of interface to the physical world, and then at the top you have some piece that wants to keep control of everything and have an overview of what's in your system and what's available from each node. It could actually be a useful thing for, say, robotics or factories or whatever. So what we have running on this OBC Lite, maybe I'll add a little footnote here. Currently, we would use this running Linux. But maybe in the future, we might also do something with Ecos, like we've seen the presentation about before. And we have a piece of software that's called the SDM. That stands for Satellite Data Model. And what this piece of software does for us is quite convenient. At the bottom end, we have our slave devices, and I'll just use as an example of my star tracker. This is sort of my baby, the thing that I've been working on. And so here we have our device name. And then we might have some messages on here. For example, I might have a message called attitude quaternion. And so that's the sort of basic piece of data that you get out of this. You take a camera and you point it at the stars, and based on that, it gives you some kind of dimensional data that says which direction relatively are we pointed. And so what we do with this SDM is we might kind of look on our network, and we have some sort of interface layer that goes and it checks all of the physical ports, and it figures out what is on all of the physical ports. And each device has its own self-describing data sheet. And so the first thing that happens is when you boot this up, you ask for that data sheet, and then you kind of get it back and you parse it. And you can kind of look for things by the device names or the message names, and you use that to figure out kind of, without the application side having to know too much, where in a system a certain thing is. So you boot up your SDM and you look for your actual devices, and then you can say, okay, I would like a device whose name is STT. And so the SDM actually kind of finds the path through all of these physical ports to the device whose self-describing data sheet on board has returned the device name as STT. Or maybe I have this message called attitude quaternion, and I tell the SDM, okay, I want a message with this name, give me the path to that. And so it automatically kind of enumerates everything, and it gives us the data path to get the message that we're looking for, or the device that we're looking for. And at an even lower level, within this message, there might be associated some variables. For example, inside this one, there's going to be some roll, pitch, and yaw, or some kind of, say, if it's a rate quaternion instead, then you have some angular rotation variables or something like that. So the sort of idea about that is that once you have this guy in place and you have the sensor managers and the networking that sort of automatically finds everything that's on the bus for you, then all you have to do is write an application that has the library interface to this guy, and it says, okay, I want this or I want that. And you don't have to care, you know, whether this physical port is USB or I2C or SpaceWire or anything like that. You're just looking for your device names and the message names. And so at the end of the day, there are only kind of two things that you have to do any kind of work on. It's this guy at the bottom. If it's not something that you've already bought from us that has this taken care of, then maybe you buy one of our generic CPU boards or something and you write your program for it. And so it has to be sort of compliant to that format. So that's the first bit of work, is that you know, you write your new device and you give it your message names and your device names and your variable names, and then you write the piece of software at the top that says find me the device that has this message or this variable or something, and everything else in between is kind of taken care of. So yeah, that's sort of in a 5-minute nutshell.
Who wrote that SDM thing?
That is written by somebody in the US. It was Utah State University.
Yep.
And I mentioned this before and said I would get back to it and didn't. It was previously sort of classified under ITAR, which is the US export regulations for munitions and space-related things.
They have to kill us all now.
Yeah.
Yes. No, but you know, we're allowed to talk about it and all of that kind of stuff. And there was even a document sort of specifying that, and that had been open for a long time, but the actual source code was not. So we were allowed to give people the binaries, and we were allowed to give them applications that were already compiled and everything. But for a while, we couldn't give anybody the actual libraries or the headers or anything like that. This recently got released from ITAR, so now we actually can distribute it to the customers and give them the example applications that they can compile and change for themselves and all of that. So this is kind of a recent thing.
Good.
And we also intend to take the source code, we had to modify it to actually work on the OpenRISC and the OBC Lite there were some endianness issues and some other kind of implementation issues, and we had to do a lot of work to get that actually running. So what we have is not exactly the same as what we initially received. And at some point we first want to do some review and cleanup of everything before we actually put it out there. But the intention is to put this out there for the community so that people can take it and do whatever they like with it and make changes, contribute it back if they feel like, or if they don't, then that's up to them.
The OBC Lite you're talking about?
No, I'm talking about the SDM.
Where can I get the OBC Lite Verilog from?
The Verilog?
Yeah.
That we don't offer, and that's actually...
That's the interesting position for
Yes.
LGPL licensed source
Yes,
code. I
and
might
there's a
know.
little bit of, I mean, I guess it's not really my place to...
I don't want to drop you in it
assertions
too
on this.
hard, but
But I
Can you buy
understand.
one though, Jeremy?
well, with doing so well, I probably could.
No. The point. So I believe if you have something that has GPL code in it, then you can also demand the source code for it, right?
So the TechEdSat owners can ask for the source code.
Yeah.
I suppose that...
And since it's an educational satellite, I'm slightly surprised that they.
Yeah, true. Actually.
I mean, that's an interesting position to be in. That TechEdSat.
Yes.
Um,
And I don't know exactly how it should be approached or how we do approach this, because the idea is that we're based on an open platform, but then there's a part that we've added to it which from our standpoint and from a business standpoint should be proprietary, and that's the
Right.
fault tolerance editions. And actually what's gone into TechEdSat does not have that yet. We put an engineering model on there that doesn't...
you're in an interesting legal position.
yes.
And I appreciate you're an engineer, it's not your problem.
Yes, yeah.
But if you give it to a customer
Yes.
and they choose to publish that RTL, I don't think you have a legal leg to stand on to stop them publishing it.
Okay.
And my understanding of one of the reasons of you using OpenRISC was NASA demanding an alternative to Leon as an open source processor suitable for spaceflight.
And that's all before I was any part of this. So
Yeah, I mean, we'd love to see this, and it is one of the dangers of the open source community, is when you get commercial companies exploiting the hard work of volunteers over the years, you know, and you can feed this back up, you know, to your management as you see
Yes.
appropriate.
No, and we have been talking about this. So.
That it can lead to an unpleasant feeling, and it can be, as some other companies discovered, can be appalling public relations. You know, there are big corporations that have got this wrong
Yeah.
and have seen very serious damage to their brand as a consequence. Now you're not Google, you're not Red Hat, you're not
No.
Sony, for example. But I do notice if we look at a big corporation like Samsung, which has OpenRISC in its desktop, you go to Samsung, underneath there's a link to their open source stuff, and you can download the RTL of the OpenRISC as used in the Samsung desktop box. And I'd encourage you to feed back up to your management that their credibility and support within the open source community does depend on them being seen to do the right thing.
Okay.
Yeah.
We've been certainly bringing that up.
Yeah, we as engineers have already discussed this quite a bit, but it is actually the management upstairs, so to say. To
Yeah.
find
Management
what's
upstairs
resolved.
need to, they do need to understand what they're getting into, and they need to think ahead. As if ORC is successful as a company, they do need to think ahead about where their reputation will sit, their legal position, and the legal position they may end up with customers like NASA. I mean, because I can bet your bottom dollar that the thought of NASA being embroiled in you're abusing open source would fall foul of several US government laws for a start, and I suspect wouldn't do your code. So I think you need to feed up probably to your marketing guy who will understand this.
Yeah, it's already on the table. We are already launching the campaign.
I would muddy the waters further and say they're using a software license for hardware. Where does that leave you?
Oh, yeah. The point is, these things are best resolved through moral persuasion, because you're part of a big defence company, and frankly, you're capable of withstanding anything anyone's legally going to throw at you. It's much better, though. Just because you have the law on your side does not mean you necessarily have the emotional, moral right on your side, and you know, for the purposes of your corporate image, it would be very good to be seen as, yes, we're not just taking from the open source community, we're giving. And there's some good reference work from IBM, where some very senior people in IBM have come out and said, actually, we didn't get the full value out of open source until we started giving back. And at that point, you become part of the community. And remember, IBM has the biggest patent portfolio in the world, and yet makes more money from open source than it does from its patents. So, anyway, but you're the, I appreciate you're the guys on the ground who just...
Yeah,
we fully agree with you on that one, and you know,
no disagreement in that part.
Do some bragging. Tell us how it got released from the ISS, and and it worked and stuff.
Well, yeah, it did get released from the...
Wikipedia has already been updated.
So, like, what does it do when it's up there? So this bit of the system is working, yeah?
Yeah, as far as I know, yes. I personally didn't get sort of any work on that project. I know that what we had on there was one OBC Lite and a few of what we call the Nano RTU.
Yep.
And the Nano RTU currently doesn't have any OpenRISC on it, actually. It's the based on the BIC core. Just because that one's supposed to be lighter weight and everything. It's in a smaller FPGA and it consumes less power.
Yep.
So that's more suitable for a small application. I guess you don't put anything big in there if it's going to be overkill. So I think that we had one OBC Lite and one of these distributed power control units, or maybe we had a custom power control unit because we didn't need that one. I don't really remember. And then we had several Nano RTUs. What I don't remember is exactly what part of the system the telemetry data is coming from that we're actually getting, because there were sort of multiple communication channels on there, and a couple of them, one of them technically didn't end up panning out, and then another one, for legal reasons, we had to just shut it off because I think we were going to try to use it as satellite to ground, but it was only legally allowed for satellite to satellite or something.
All right.
Something of that nature, and so then we didn't get all of the data out of it that we were actually supposed to. But there was still one, I think it was that we couldn't get any uplink channel because of that. So we only have a downlink channel, and everything that gets collected and put through the downlink channel was working properly. So yeah, it is alive, but it didn't get exactly all of the functionality that we were looking for.
Because of missing license.
Yeah.
Are the slides going to be up on the internet?
What's that?
Are the slides going to be up on the internet?
Probably not this one.
Cool. Yeah, thanks for talking about that.
Yeah,
we all saw the photos, and that's the coolest thing I've seen in a while.
Yeah. Well done getting up into space.
Yeah.
Good news.
When did it actually go up?
They launched it like the end of July or something, if I remember correctly. It was on the Japanese cargo vehicle, and then they,
so it did go up in July, but they've only just started it up now.
Exactly. They were originally planning to actually physically release it earlier, but then they had some problems, and they had some other problems, and so the original plan was to wait like a month or so, but then they had some other delays, and they took an extra month or two.
But that's just mean to let you wait for 3 months without knowing.
So in July, it launched in July?
Yeah, as far as I know, I think it was the end of July that they actually...
There was a press release going out 2 days ago.
Yes, I saw that, but it talked about the 4th of October. That's the deployment, not when it was launched.
It was the Japanese HTV launcher that they used.
Yeah, because the Dragon thing went up recently, right?
Yes,
I thought it had gone up in that because of the timing of the press release. But then I'm like, 4th of October, how did it get up there before the rocket launched?
It was the Japanese launch vehicle that did this. So the whole sending the CubeSats to the ISS was a Japanese initiative.
Yeah.
And they took half of their space and made that available to Japanese CubeSats, and then they took the other half and made it available to foreign or international collaborations. So they had they do this in units. Like a 1U is 10 centimeters by 10 centimeters by 10 centimeters, and so they had a total of 6U worth of space. So they had one Japanese satellite that was 2U, and another that was 1U, and maybe another one that was 1U.
Yep.
And then they took 2 more that were 1U each.
So they're all like 10 centimeters cube.
Yeah.
Oh, okay.
So these are small guys. It's not
One
like.
are Japanese is lead.
Yeah, that's right. There was one of
Okay.
these that they were supposed
So
to do
meaning
Morse
less
code
down to
messages or something.
Okay.
Cool.
I don't know if that one succeeded or not. That was built by a company in Japan, I guess.
Sweet. How much do they weigh, roughly? Less than a kilogram or something?
Yeah, I think it's less than a kilogram. Because if you have something, the Japanese guys who I used to work for the university, they have been making a series of micro satellites that are like 50 centimeters cubed, and those are about 50 kilograms. So the kind of scales down. It's about a kilogram or two for the buy.
Nice one, man.
Okay.